Welcome to Unacademy, India's largest e-learning platform for GATE and ESC. GATE and ESC. And we are discussing a subject called electronic devices and circuits, electronic devices majorly. It's going to be lecture number 18. And we will be discussing problems on PN junction. In the last class also, due to some technical reasons, we stopped at this. We want to finish off this topic. Yeah. Good evening. So we want to finish off this topic as early as possible, but due to a technical problem, yesterday we stopped at 1.5 hour. That is, but by 8:30, 8:45 we finished the class. Right? We'll continue. We will discuss the most important problems. Though recently problems, we also discuss everything. Right? So I wish you again a happy Merry Christmas from Unacademy. Unacademy is off. Is very happy to give you wish you a Merry Christmas. May you continue to bring joy to the world today and forever. Right? So myself, Vasu, good evening, Vasu. So myself, Shravan Kumar, I have a master's degree from JNTUH in VLSI System Design. So I have 10 plus years of teaching experience, and the subjects I have taken is EDC, which is right now we are discussing. And we have analog and digital circuits also. Analog I am teaching on app, that is Unacademy app, and EMFT and digital are about to come. So you have Unacademy Plus subscription, which will get you 10% discount. 10% discount. So on Plus subscription, what do you mean Plus subscription? Plus subscription is like you will have live classes. You will have live classes and attend all live classes. You will have crash courses also. You can attend all the crash courses. You have weekly tests. So time and again I am mentioning this. Weekly tests are very important for those who are preparing for GATE exam for 2022 or 2023. Very important. Test is very important. GATE is not just about theory and listening. It's all about how testing yourself where you are. And for every 4th hour, you are going to have a doubt solving session. Which is very important. You will have English and Hindi classes. You have two classes will be in English and Hindi. And you have a rank improvement batch. You have something called rank improvement batch. Those who are very strong at basics. And want to improve their rank. So this will be very much useful. And we have something called Iconic Batch. Along with Plus subscription benefits, Iconic Batch students will get a benefit of personal coach, and you'll have a study planner. You'll have a study booster sessions. You will have a personalized test analysis, and then you have a preparatory study material. You'll have a preparatory study material will be available. Okay. And for Plus subscription, you'll have 12 months for 27,225 rupees. You can use my referral code SVS10. You can use my referral code SVS10 for 10% discount, right? For 18 months, you will have 34,650 rupees. Might be changed also right now, but you can use this for 10% discount. And for 24 months also, you will have 39,600. Okay. For Iconic, you have 12 months and 24 months. So 45,225 rupees is the fees right now, and you can use referral code, that is 10%, to get a 10%. 24 months is going to 66,600. 66,600 rupees is what. So you can pay using EMIs. You will have EMI facility. You have credit card facility. You can pay through credit card facility. You have wallet facility. So you have many things to pay. If you are desired to pay, you can pay through anything. All of this, right? So those who did not download the Unacademy app, I request you to download the Unacademy app and follow me. Follow me. And Unacademy, how to download the Unacademy app is just go to Play Store and type Unacademy Learning app, and you will get like this. Just click on install. It will be installed in your mobile phone. You install many. Sandhya, good evening. Welcome. You will have many other apps also. Just try to download this app, which will be very much useful for you, right? So how to do, what you need to do is step number 3. It is important. You have to choose GATE ESC. As I told you, we are the Unacademy is in NEET PG, GATE ESC and IIT JAM for 3 to 4 years of session. CSIR UGC NET and NTA UGC NET, MPSTs, all depending on different cases you have. So, but you have to choose ESC, GATE and ESC, engineering science examination, And step 4 is you need to choose this plus subscription. You will have other classes, so free classes and special classes. Which of them are free? But this plus is a paid batch. So for plus, you need to pay the amount which I have mentioned earlier. And just click on subscription. Click on get subscription. Okay. And now this is a special class series which we started targeting 2022-2023, named as Know Your Basics, which is completely free of cost, and you will get the best of India's top educators in this also, and they'll give instruction and guidance. And to understand subject-wise strategy to crack GATE 2022-2023. Right, you can understand the subject-wise strategy to crack, and a complete roadmap approach for every subject you will have for every branch, right? And every branch means you will have mechanical engineering, civil engineering, electrical engineering, ECE, CSIT, and chemical engineering. And it started already on 20th of December. Okay. And we have a special targeting 2023, we have a course called Ascend. So which will be for electrical and ECE, which was started on 21st of this December. Recently it started, and the course will be in English and Hindi. And these are top educators of Unacademy. For triple E, you can use EE Gate 10. EE Gate 10 is a user code, and for EC it is going to be ECE Gate 10. ECE Gate 10 is a user code. Targeting 2023. And for targeting 2022, we named it as Evolve. Evolve. This also started on 21st of December. And the course will be again in English and Hindi. And these are top educators of Unacademy. And for EC, you should use ECE Gate 10. And for triple E, you should use EE Gate 10. So this is a very important Unacademy combat. So this will be on 29th of December from 6 p.m. You can so combat goes live combat test. So you should use a code SVS10. You should use my code SVS10 to unlock and register. So those who get 1 to 3 ranks, they'll be now we are also changing. I think laptop is going to be given for the first top fellow. Laptop for 1, and you have 2 and 3 special prizes. Special prizes also 2 and 3. For even for rank 4 to 50 also we have Amazon vouchers. Just a minute. I'll let you know what is. Sir, second prize is going to be iPad Mini. Second prize is going to be iPad Mini, and the third prize is going to be AirPads. Will get AirPads. It's going to be iPad Mini, and you'll get AirPads. So the latest version of this, I'll provide it in the next slide, next day. And in tomorrow's class, I'll provide it. Just a second, sir. Just give me a second. Let me go live. Okay. So next is going to be, you can follow me. You all can follow me. You all can follow me on Unacademy. You all can follow me on Unacademy. And this is my user. This is my user. This thing. Yeah. Now just we'll go back and see what we discussed in the previous class. I think we have discussed some problems. This problem we have discussed. 1, 2. Third problem we have discussed. Fourth problem. Fifth problem. Sixth problem. 7 problems. 8 problem. We have discussed 8 problems. We have discussed 8 problems in the previous class. We have discussed 8 problems in the previous class. Now we will continue. Now we will continue our discussion today. The problems. So now we have come up with the new latest problems. This is the latest problem of GATE 2019. GATE 2019 problem. I think this is 1 mark question. 1 mark question. GATE 2019. Hope you are having your pens and papers with you. Hope you have pens and papers with you. Hope you have pens and papers with you. Now, see what he's saying. See what he's saying. The problem is, in an ideal PN junction with an ideality factor of 1 at a T is equal to 300 kelvins, the magnitude of the reverse bias voltage required to reach 75% of its reverse saturation current, rounded off to the 2 decimal places, is. He is also given K value, H value, Q value. So he has given T is equal to 300 degrees Kelvin. Ideality factor is nothing but eta. Eta is equal to 1. Eta is equal to 1. The magnitude of the reverse bias voltage required. The magnitude of the reverse bias voltage, that is VB or VR. Or VR, whatever, voltage, some voltage, or VD diode. Let's consider diode. PN junction diode is saying, right? VD. How much is VD required? To reach the voltage required to reach 75% of its saturation current. Oh. So he's saying the current should reach 75% of its reverse saturation current. Of current. Round it up to 2 decimals is asking. Round up to 2 decimals is asking. He has given K, T has given, H has given, Q has given. Okay, why did he give H? We don't know. So simply what is asking, sir? He is asking diode voltage. He is asking diode voltage, which will make this current, in reverse bias, which will make this current reverse bias having 75% of I naught. So simple. Is that clear? Did you understand the problem first? Did you all understand the problem? This is latest 2019 problem. Did you understand the problem first? What is asking first? He is asking diode voltage, the reverse bias voltage. Reverse bias voltage. He is asking the reverse bias voltage first. First, he is asking for reverse bias voltage. So, how will you get the answer? How will you get the answer? What will be the answer? Very simple. I will try to tell you. You need not worry. Sir, you need not worry. It's very simple. So we know I, the current I, the diode current I is equal to I naught into e power V by eta Vt minus 1. Eta Vt minus 1. Eta Vt minus 1 is what? What is the equation? Is what is the equation, right? So what is saying, this I should become 75% of I naught. So this I should become 75% of I naught. Means what does it mean? What does it mean? 0.75% of I naught, and it is in reverse bias. It is in reverse bias, I should say. So minus 0.775 I naught, right? So he is asking, and eta also he has given. Eta also is given 1. He is asking for VD. Okay, what we'll do is minus of 0.75 I naught is equal to I naught into e power V by eta is 1, Vt minus 1. So what happens, sir? This I naught will get cancelled. I naught and I naught will get cancelled. So what will be remaining? Minus 0.75 is equal to e power V by kt by q, or t by 26,700. Sorry, 11,600 minus 1. So if you bring minus this side, so latest problem. Mahendra, what? Okay. So no problem, Mahendra. We just listen. Okay. We'll get 1 minus 0.75 is equal to e power V by, we'll consider this as, did you mention any temperature as 300? We'll take it as a 26 millivolts. 26 into 10 to the power of minus 3. So we'll get 0.25 is equal to e power V by 26 into 10 to the power of minus 3. So if we apply, so what you'll get is V by 26,000, 26 millivolts is equal to natural logarithm of 0.25. So what you'll get is V is equal to 26 into 10 to the power of minus 3 into ln of 0.25. Yeah, can somebody tell me what will be the answer? Can somebody calculate? What would the answer? You please calculate simply 26 into 10 to the power minus 3 into ln of 0.25. Natural logarithm of 0.25. No one is there to calculate. Hello. Minus 36.04 millivolts. Minus 36.04 millivolts. So minus 36.04 millivolts. So what he was asking is, yeah, he's asking in millivolts only. Sir, in case if he wants to calculate in different way, you can also calculate. If somebody wants, sir, I have considered directly Vt is equal to 11,600, or sorry, if somebody wants to calculate Vt is equal to, they calculate kt by q also. So probably you may get some different value, that will 35.82. So your answer will be considered from, let's say, from 35.80 to 36. minus 36.10 kind of thing. You need not worry, he will give the range. Exact value may not be correct, but he will give the range. He will give the range. Is the point clear? He will give the range of voltages. So why this is minus? Why did we get minus? Why did we get minus? Because it is reverse biased. It is reverse biased. It is reverse biased. The minus sign indicates it is minus reverse biased. Sir, problem is very simple. Problem is very simple. But the only thing is you need to understand the problem first. First is you need to understand the problem. If you are able to understand the problem very clearly, that itself is great. That itself is great. First thing is just pay attention, understand the problem. Is the problem difficult? Is the problem difficult? No. Do you think this is a great problem? Yes, this is a great problem only. This is a great problem only. Simple. Only thing is you need to know this formula. If you know this formula and logic, you can calculate this. How much time it will take? Hardly 2 minutes, not even 1 minute only. As I am explaining, it may be taking a lot of time. But for you, when you are doing the examination, you will do it very fastly. 0.036, correct Sandhya, but he is asking in millivolts. That is the problem, Sandhya. What in the given problem is asking in millivolts. You should see, right? So your answer will write 0.036 may be right. This is in volts, but is asking in millivolts, so it's going to be 0.36 millivolts. 36 point something you'll get. Yes or no? So be careful while you are writing the answer. So if you write 0.03, 0.2 decimals, 0.03, this is going to be 0.03 millivolts. 0.03 millivolts. Is that answer right? No. Answer is 36 point some 04 millivolts. 36.04 millivolts. You need to be very much careful. While you are writing the answer, filling the blanks. So you will do exactly a correct answer. Till this point, your answer is correct. Everything is correct. But what happens is you should be very attentive while writing the answer, while answering the question. You should be very attentive. Okay, be careful. He asked in the millivolts. Okay, we'll move on to the next problem. This is in 2018 GATE. 2018 GATE problem. 2018 GATE thing. What is the theory question? It's a theory question. What is saying? In a PN junction diode at equilibrium, which one of the following statement is true? Which one of the following statement is not true? Remember this. To confuse you, he has given not true. Which one of the following statements is not true? Which one of the following statement is not true? This is saying which one of the following statement is not true. Which one of the following statement is not true? Okay. Which one of the statement is not true? This is not true. Very important. So the hole and electron diffusion current components in the same direction. Okay. The hole and electron drift current components are in the same direction. Okay. The holes and electron drift current in opposite direction. The drift and diffusion. Acha, he's talking about. Let me draw the PN junction diode now. This is P. This is N. Let's say some positive voltage you are giving here. Some negative voltage you are giving here. So what he's saying? He's saying which of the following statement is not true. Which of the following statement is not true? He's talking about diffusion and drift current. So holes will diffuse from Holes will diffuse from P region to N region. Holes will diffuse from P region to N region. So the drift current, so the diffusion current Jp is in this direction. In this direction, the electrons will diffuse from N to P. N to P. So electrons will diffuse from this direction. This direction. But this I'll write this electron holes diffusion. Sir, understand very clearly. Understand very clearly. Have patience and understand. So this is electron direction. When the electrons are moving in this direction, their corresponding current is going to be in this direction. So Jn diffusion. Jn diffusion. Okay. Jn diffusion. Okay. Next, he's talking about drift current. Drift current. He's talking about drift current. So drift means what? Drift means what? What happens if drift means? Drift current. So we have studied that for a p-n junction at equilibrium, the diffusion should be opposite in drift. Diffusion should be opposite in drift. So in the drift current means, for the drift current, Jp drift we need to know, and Jp drift and Jn drift. We need to find out the directions of Jp drift and Jn drift. Jp drift and Jn drift. Right? Jp drift and Jn drift. So when you are applying here, the Jp drift current will be in this direction, equilibrium, that is minority charge carriers, right? The minority charge carriers, this is what the minority charge carriers in N types are holes. So they are moving in this direction, electrons in the P will move in this direction. So their drift current is in this direction. This is going to be Jp drift. Jn drift will be in this direction. Now we got all the four directions. So Jp drift direction, Jn drift direction, right? The Jp diffusion direction, Jn diffusion. Right? He's talking about equilibrium. He's talking about equilibrium, no. He's talking about equilibrium. So now what is that? The hole and electron diffusion current components are in the same direction. Diffusion currents, hole and electron. So diffusion currents. This is a hole direction and electron diffusion direction. Correct. Both the hole diffusion, current diffusion, electron diffusion currents are in the same direction. Yes, this is correct. This statement is correct. Now we'll discuss about statement 2. The hole and electron drift current components are in the same direction. The hole drift current in this direction. Diffusion drift current of N is also in the same direction. So statement 2 is also correct. Statement 2 is also correct. Now statement 3. On an average, holes and electrons drift in opposite direction. Yes. So yes. Holes are drifting in this direction. Electrons are diffusing in this direction. So this statement is also correct. So what is remaining? Fourth one. On average, electrons drift and diffuse in the same direction. So electron drift is in this direction. For D, what is saying, sir? Now we can consider electron drift. Electron drift direction is in this direction. So what is electron diffusion? We have seen electron diffusion is this. I'm not talking about current. I'm talking about just electron and diffusion. Electron drift and electron diffusion. So electron diffusion in this direction. So statement number 4 is wrong. So what should be our answer, sir? Our answer should be 4. Did you understand? Our answer should be 4. Our answer should be 4. Our answer should be 4. So the electron drift current and diffusion currents are not in the same direction. They are in the opposite direction. They are opposite in direction. So at diode equilibrium, So is the point clear? Is the point clear? Okay. Okay, we'll move on to the next problem. This is again 2018 gate. It is again 2018 gate. A PN step junction diode with a contact potential of 0.65 volts has a depletion width of 1 micrometer at equilibrium. Okay. The forward voltage at which this width reduces to 0.6 micrometers is contact potential is nothing but V naught. V naught is equal to 0.65 volts, and the depletion width of what is depletion width W is going to be 1 micrometer. Is going to be 1 micrometer. The forward voltage for which width reduces to 0.6 micrometers. Very simple. Very simple problem. 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 So he is asking about what would be the V forward voltage for which this W becomes 0.6. This W becomes 0.6 microamperes, microvolts. Okay. Now we will calculate. Very simple. We know the W. What is the formula for W? We know that W is going to be 2 epsilon by Q into 1 by NA plus 1 by ND into V naught. Let's say this is going to be W1. It's going to be W1. It's going to be W1. Now W2 is what is going to be, sir? It's going to be 2 epsilon by Q into 1 by NA plus 1 by ND into V plus V naught. V plus V naught. So what is W1? W1 is 1 micrometer. W2 is going to be 0.6 micrometers. Its corresponding V naught is going to be 0.65, I think, which has given. Yes. So what would be VF means V naught plus VF we need to find out. So this is V naught, VF plus V naught, whatever. So simply what we need to do, sir? So write W2 by W1 is equal to square root of 2 pi epsilon by Q into 1 by NA plus 1 by ND into VF plus V naught by same again 1 by square root of square root of 2 epsilon by Q into 1 by NA plus 1 by ND into V naught. So simply what, sir? You substitute this, is going to be 0.6 by micrometers by 0.1 micrometers. So everything will get cancelled. So what will be remaining? What will be remaining is VF plus V naught by V naught. So this will get cancelled. This is sorry, this is one micrometer, right? I'm sorry, this is not 1.1. This is going to be 1 micrometer. It's going to be 1 micrometer. Are you all listening or not? Are you all listening or not? Are you there? So you know the value of V naught. You know the value of V naught. So simply find out 0.6 whole square is equal to Vf by V plus V naught. I mean V naught. Achha, this is not plus, right? Just a second. It's going to be V naught minus Vf. You guys are not saying anything. This is minus na. That is the reason why I'm getting something wrong here. Okay, no problem. No problem. Sometimes happens. Sometimes it happens. Need not worry. Okay. What is 0.6 whole square? It's going to be 0.36 is equal to Vf by V naught minus this is going to be 0.65. I think he has given. How much he has given? 0.65. 0.65. So if you bring it this side, let's find out what is going to be Vf. Overall square root cancelled. Now if you square it will be cancelled. Nah. If you square it, then only square root will be cancelled. One side, square on both sides, Vasu. Square it on both sides. 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 Okay, you got some value. Sanjay got some value. So all this will be cancelled. Vastu, all this will be cancelled. 2 epsilon by q, 2 epsilon by v, 1 by nda plus 1 by nd, everything will be cancelled. You have v naught. Oh, here some mistake has happened. Just wait. Sandhya, this is what the mistake we have done. I'm really sorry. So this is V naught by V naught minus Vf by V naught minus Vf by V naught minus Vf by V naught. So we'll get 0.36 is equal to 1 minus Vf by V naught. So Vf is equal to V naught into 1 minus 0.36. So Vf is equal to 0.65 into this is going to be 0.64. So Vf is going to be what? Correct. V naught minus Vf. Sandhya correct. Sandhya correct. Yeah. Correct. Now tell me what will the value? 0.6 minus 0.64. What is the VF? Clear something called 0. Correct, 0.41. 0.417 something will get. 0.417 something will get. Correct, Sandhya. Correct answer. This is going to be the 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 answer. 0.416 or 416. Correct. Next problem. Age. I think it is not so clear, but still bear with me. Okay. A junction is made between P minus silicon with a doping concentration of Na1 is equal to 10 to the power of 15 centimeters cube per centimeter cube, and PSI with a doping concentration of Na2 10 to the power of 17 per centimeter cube. Boltzmann constant is this, electron charge is this. Assume 100% acceptance, ionization, all these things are not required. At room temperature T is equal to 300 degrees, the magnitude of the built-in potential in volts, correct to 2 decimal places across the junction will be. What is saying, sir? Look at here. What is saying. I'll try to explain you. This is 2018 gate problem. This 2018 gate problem. And not required this is. Anyway. He's saying this is P minus and this is P. He's saying P minus and P with an acceptor concentration of Na is equal to 10 to the power of 15. This is Na is equal to 10 to the power of 17. 10 to the power of 17. So this is having high concentration of acceptors. High concentration of acceptors when compared with this P minus. High concentration of acceptors when compared with P minus. So I'll tell you. So what's happening here is. So and he's asking for something called built-in potential V0. Built-in potential V0. Sir, simple, sir. Simple. You need not worry. I'll explain you. So now theoretically, I'll try to explain what's happening here. You all should know. I have to explain you the theory part of this. Then only you'll understand the solution. Let's say this is going to be P minus and this is P. So this is a EFI. What is EFI? Fermi level of intrinsic concentration. Intrinsic concentration. Right? Intrinsic concentration. Right? So what it is saying, sir? He has some Ni is equal to 10 to the power 15, 10 to the power 17. So generally, if the doping concentration is high, now what happens? This Fermi level, the new Fermi level will move towards, as in P region, it will be moving towards. This is EV. It will be moving towards very closely to EV. Yes or no? in p-type material, but is acceptor materials. So which is having, this is Na is equal to 10 to the power of 15. This is Na is equal to 10 to the power of 17. 10 to the power 17, which will be very close. Which will be very close to this, sir. So this will be very close because its concentration is very high. This will be, it will be like at here. So this portion, this will be very close. So this is very close. As the concentration is increasing, this Fermi level, this new Fermi level, I should say EFP, and this is, I should say EFP minus. EFP minus. Are you able to understand what I mean? Are you able to understand what I mean? So when the acceptor concentration is increasing, this Fermi level move towards valency band. Fermi level move towards valency band. Yes or no? Fermi level move towards the valency band. Fermi level moves towards the valency band. Did you get my point? Did you get my point? Are you able to get what I mean? So for this, what is the formula? EFI minus EFP minus is equal to, we know the formula. We know the formula. What is that? KT into ln of Na by Ni. For this also, this is going to be EFI minus EP is equal to, again, KT into ln of Na by Ni. Can I say this is going to be Na minus, so that we will have a difference. So this is going to be Ni. Now what happening is asking about when these two brought together, what happens, sir? How the new energy level will be? How the new energy level will be? I'm just trying to draw the energy level, how the energy levels will be. I'm just trying to draw. So this is what the potential V0 is asking. Yes or no? This is the potential difference. We have seen this is going to be P minus, and this is going to be P. So this height is asking. This height is asking. This is also V0. So if you minus these two, you'll get this. If you minus these two, you'll get the original value. You'll get the original value. So what is that minus? So simply what you will get is, the formulas will write. So EP minus EPI is equal to KT into ln of Na by Na minus will get. Na by Na minus will get. So this is going to be KT into ln of 10 to the power of 17 by 10 to the power of 15. EP minus. Right? So, but what is this E? E, we know that E is equal to VQ. E is equal to VQ. So, from this I can say this is going to be V0 into Q. V0 into Q. V0 into Q. So, from this V0 is equal to KT by Q into ln of 100. ln of 100. So, what is V0? Now, substitute all these values. K value is given, T value is given, Q value is also given. Temperature, did he mention the temperature? Yeah, this mentioned T. So KT by Q, K 1.3 10 to the power of minus 23. All the formulas which he has given, 1.32 into 10 to the power of 23 minus 1.3 into, and Q, T is equal to 300 minus 23, 300 by Q, 1.602 into 10 to the power of minus 19 coulombs into ln of 100. So you will get the value of V naught. Simply you will get the value of V naught. Tell me what is the value of V naught then? Tell me what is the value of V naught then? Tell me what is the value of V naught? Did you calculate it or not? Did you calculate it or not? Okay, I'll do one thing. I'll tell you the answer. You'll get 0.1197. As he is asking for what? Sorry, he's asking for built-in potential. Correct to two decimal places. So what you'll get is 0.11. Either 0.11 you write, or you can write approximately 0.12 volts. 0.11 or 0.12 volts. 0.11 or 0.12 volts is a value. 0.11 or 0.12 is the answer. 0.11 or 0.12 is the answer. Okay. Okay, shall we move on? So this is what the answer, sir. This is what the answer. This is what the answer. Hope you understand this. Hope you understand what I mean. If you understand this, you are done with the problem. So next problem is 2017. Earlier was 2018. Now it's going to be 2017. An N plus and N silicon device is fabricated with a uniform non-degenerate donor doping concentrations of ND1 and ND2 corresponding to N plus and N regions at operation temperature T. Assume the complete impurity ionization KT by Q is equal to 25 millivolts. Okay. Intrinsic concentration Ni is equal to 1 in 10 to the power of 10. What is the magnitude of the built-in? Same problem. Same problem. Same problem, sir. In 2017 and 2018, he asked same problem. In 2018, he asked P minus and P. He asked P minus and P. He asked P minus and P. Here he simply is asking N plus and N. N plus and N. Same thing. Can you do it? Can you do it, sir? Can you do it now? Same problem. Same problem. Same problem. Same what? Again, I'll show you. Same thing. Same V naught is asking. Same V naught is asking. So he is saying this is N plus and this is N. Earlier it was P minus and P. Now it is N plus and N. N plus and N. N plus and N. I'll tell you second solution. I mean solution. I will tell you the solution. I'll tell you the solution very easily. Simply is asking V naught is equal to, we know that KT by Q into ln of ND NA by Ni square. This is what we know already. Right? We know that KT by Q. Very simple. This is I am talking. So what we can do, sir? What we can do? What we can do is, so this is going to be ND1 by Ni square by Na. Na square by Na is going to be KT by Q into ln of ND1 by ND2. Directly you'll get the answer. Substitute all the values and you'll get the answer. Substitute all the values and you'll get the answer. This is second method. This is method number 2. This is method number 2. This is method number 2. Previous was theoretically explained and answered. Now this is method number 2. This is method number 2. It's going to be method number 2. So what will be the answer, sir? I'll get 0.173 volts. 0.173 volts. And so answer is going to be this. Answer is going to be this. In fact, all the values were same also. You can see here. Almost same. Here it was 17, 10 to the power 15. Here it is 18, 10 to the power 18, 10 to the power 15. Only difference is this 10 to the power 17 earlier it was given. Here it is 10 to the power 15. 10 to the power 15. Nothing new, sir. Nothing new. Same problem. So you can expect this kind of problem in coming days also. Same kind of problem you can expect in coming days also. Is the point clear? Is the point clear? Okay, we'll move on to the next problem. So this is also a very good problem. There is 2016 gate. 16 gate. Actually, you can easily answer this question. Sandhya, volts. Sandhya, what is volts, Sandhya? Yeah, 0.713 volts only. Correct, Sandhya, correct. Your answer is correct. Now we'll move on to the next topic. So this is a theory problem. I copied it from somewhere. Study the problem, sir. The VI characteristics of a 3 types of diodes. The VI characteristics of 3 types of diodes at the room temperature made of semiconductors X, Y, and Z are shown in figure. This is the VI characteristics. Are shown in figure. Assume that the diodes are uniformly doped. Assume that the diodes are uniformly. The doping concentration is same and identical in all aspects. There, except their materials. They are made up of different materials. Means one may be germanium, one may be silicon, one may be gallium arsenide. So like this. Okay. If EGX, EGY, EGZ are the band gaps of X, Y, and Z respectively, then okay. So then which one of the following is correct? So EGX is greater than EGY, EGY is greater than EGZ, or EGX is equal to EGY is equal to EGZ, EGX is less than EGY is less than EGZ. Sir, one thing, can tell me the answer? Can you guess the answer? Can any one of you guess the answer? Just guess the answer. A, B, C, D. Beautiful problem. This is very beautiful problem. Simple problem. Very beautiful problem. Vasu said D. Sandhya said C. Vasu, no relationship among these band gaps, huh? Okay, I'll explain. Very simply. You can see we have energy gaps. We have something. Right? Is talking about energy gap. Energy gap of germanium is what, sir? How much, sir? Was that not 0.7? what is the energy gap of silicon? Is it not of 1.1? 1.1? 1.1? What is their cut-in voltages? What is their cut-in voltages? Is that not 0.3 volts? And what is this cut-in voltage? Is that not 0.7 volts? So in VI characteristics, we always calculate the cut-in voltage. We always calculate the cut-in voltage. So this is going to be V gamma 1, V gamma 2, V gamma 3, V gamma 3, V gamma 3. So if the energy gap, so we know that V gamma 1 should be less than V gamma 2 should be less than V gamma 3. Sanja is listening, right? So V gamma 3. So similarly, can I say this Eg1 is less than Eg2 is less than Eg3. So, but he is mentioned here in terms of EGX. XYZ is simply mentioning. So, I can say EGX is less than EGY is less than EGZ. Did you understand? Did you understand, Vasu? So, based on this concept of energy gaps, where cut-in voltage are, if the energy gap is changing, cut-in voltage is also changing. Cut-in voltage are changing. So, when the cut-in voltage is less, means their energy gap is less. Their energy gap is less. Is the point clear? If the cut-in voltages are less, their energy gaps are less. If the cut-in voltages are less, the energy gaps are less. So EGX should be less than, EGY should be less than EGZ. So the answer is C. You are right, Sandhya. I was explaining to this for Vasu. Vasu, did you understand? Vasu, did you understand? Okay, we'll move on to the next problem then. Next problem. An abrupt silicon PN junction has the Na is equal to 10 on P side and Nd on N side. At so at did we discuss the problem yesterday? I think we have discussed same problem yesterday. So simply what is saying, sir, it's going to be V naught is equal to again Vt into ln of Na Nd by Ns square. I think we have already discussed this problem yesterday. Na Nd by Ns square. So V naught is equal to 300 means 26 millivolts. Ln of Y2 discuss again 10 to the power of 17 into 10 to the power of 16 by, anyway it has come, that's why we are discussing. Ns square is going to be silicon 1.5 into 10 to the power of 10 whole square. I think we got V naught is equal to 0.757 volts. Okay, this is already discussed. Sorry. Now we come to the next problem. Okay, now we'll see the next problem. Boron is implemented into an N-type silicon sample. N-type silicon sample, Na is equal to 10 to the power of 16, forming an abrupt junction of square cross section with area. Oh, this is going to be This is going to be 2 into print mistake 10 to the power of -3 per centimeter square. Assume that the acceptor concentration in the P type is Na is equal to 4 into the power of 80 centimeter square. Calculate. This problem also we have discussed, right? This same type we have discussed, I think. Same type we have discussed. This problem also we have discussed. Same formula, V naught is equal to how to do it? V naught is equal to calculate Vt into ln of Na by Ns square. After that you calculate xn naught. Xn naught is equal to W into Na by Na plus Nd, and is asking xp naught. Xp naught is equal to W into Nd by Na plus Nd. Then you know the Q plus value. What is the Q plus there? Q Na into A into xn naught or xp naught. Then Ep naught is also, you know, Ep naught is going to be minus Q by epsilon into Nd xn naught. All the formulas we know. Just you do one thing. All the formulas we know. Just do one thing. You note, like, you do it like a homework. Assume that is going to be a homework. Okay, next problem we'll see then. In an abrupt PN junction, as Na is 9 into 10 to the power 16 per centimeter cube, N is equal to 1 into 10 to the power 16 cube. The total depletion width is 3 micrometers. The depletion width of the P side is going to be, it's actually xp naught. W into xp naught is going to be Nd by Na plus Nd. Simply everything is given. 3 micrometers, 3 into 10 to the power of minus 3 or minus 6, I think, micrometers into Nd is asking in micrometers. Is asking in micrometers means let's leave it. 3 into Nd is how much, sir? Nd is 1 into 10 to the power of 16 by 9 into 10 to the power of 16 plus 1 into 10 to the power of 16 is going to be 3 into 3 by 10. I'll take into 10 to the power of minus 6 anyway. It will live there. Is it not 0.3 micrometers? 0.3 micrometers. You know 0.3 micrometers? Simply answer is B, 0.3 micrometers. Simple problem, very simple problem. Very simple problem. Very simple problem. Okay, we'll go to the next problem. Quickly, we'll go to the next problem. Consider a silicon PN junction at room temperature having the following parameters. Xn naught is equal to 0.1, Xp naught is equal to 1.0 micrometers, Ni is equal to 1.4 into 10. Oh. What is this? 1.4 into 10 to the power of 10 per centimeter cube. This is going to be E naught he's talking about. Some mistake has happened. 8.85 into 10 to the power of minus 14. The typing mistake. Force per centimeters is going to be Vt. Vt is going to be 26 millivolts. 26 millivolts. He's asking building potential junction. That is nothing but V naught. Peak electric field E is asking, or E naught. E and E naught. E and E naught. Right? So what is given? Everything is given. Now we will see what is V naught. V naught is going to be Vt into ln of NA ND by NS square. So ND is given. Do we have NA value? No, we need to calculate NA value. We need to calculate NA value, but he has given this C. See how to calculate this. How to calculate this? So now NA we don't know. NA we don't know. NA we don't know. But we know one formula. But we know we have Xn naught, we have Xp naught, and we have ND also. So we know that Xn naught by Xp naught is equal to Na by Nd. So from this we can calculate Na. So Na is equal to how much, sir? Xn naught by Xp naught into Nd. Na is going to be, what is Xn naught? 0.01 microohms by Xp naught is going to be 1 micro. I like to write 1 into Nd is going to be how much? 10 to the power of 17. 10 to the power of 17. Simply Na is going to be how much, sir? Accept our constant is going to be 10 to the power of 16 per centimeter cube. Na is going to be. Are you following me? Sir, just post your question if you are unable to understand or if you want me to slow down. If you want me to slow down, you can just post me. You can just post me. Are you able to follow me or not? Are you able to follow me or not? Okay, okay. If you are unable to follow me, you can just post me. So now substitute this here. V naught is equal to VT. Did he give VT value? 26 millivolts. Yes, is given 26 into 10 to the power of minus 3 into ln of Na Nd. Na is how much? 10 to the power of 16 into 10 to the power of 17 is Nd by Ni square. Did he give Ni value? Yes, 1.4 into the power of 10. 1.4 into 10 to the power of 10 whole square. So calculate and let me know what is the value of V naught. Calculate and let me know what's the value of V naught. Calculate the value of V naught. How much value it's going to be? 0.76. 0.76. Correct. Correct, Sandhya. Correct, Vasu. Correct, Vasu, you are right. 0.76 volts is the right answer. Correct, Sandhya. Correct, Sandhya. Correct. So first is V naught is what we got is 0.76 volts. And now he's asking us to calculate E naught also. Now if you are calculating E naught, easy. Now what is E naught? E naught value? E naught value, we know that minus Q by epsilon into Nd into Xn naught. Nd into Xn naught. Nd into Xn naught. We'll get a minus Q 1.602 into 10 to the power of minus 19 minus 19. ND is how much? How much we got ND? And D is 10 to the power of 17. Okay. 10 to the power of 17. Xn naught. Xn naught is micrometers. 0.1 micrometers. All these are in centimeters. All these are in centimeters. So convert them into micrometers. Xn naught is going to be 0.1 micrometers. Sir, no? So, but we want in centimeters. So micrometers. This become micro into 100. If you make it, it will become centimeters. Yes or no? Yes or no? Yes or no? By 12 is the multiplication factor. 12 E into 8.85 into 10 to the power of minus 14 E naught. So how much is going to be E naught? E naught is given anyway, right? Epsilon naught is given, but it's a factor of, see, dielectric constant factor is also given 12. That is the reason why we consider here. This is dialectrical constant. Dielectric constant 12. Okay. So epsilon naught is going to be what? Now tell me what is the value of this. Tell me what is the value of this. Just calculate simply. Just calculate simply. How much we get the value? (1.5) into 10 to the power of minus 12. Why did you get 10 to the power of minus 12, madam? It's 10 to the power of minus 4. Xn naught. Xn naught, you apply Xn naught. What is Xn naught value? 0.1 micrometers. Convert them into centimeters. As everything is centimeters, we convert them into centimeters also. You just tell me we are supposed to get minus 0.15 into 10 to the power of 6 volts per centimeter. That is minus 0.15 megavolts per centimeter we got. That's what we got, right? 1, 2, 3, 4, 5, 6. Correct. Correct, Sanjay. Correct. You're right. Sanjay, you're right. I am just representing with mega. I'm just representing with mega. That's it. Everything is fine. Everything is correct. Everything is correct. You got the same answer. You got the correct answer. E naught is going to be 0.15 megavolt per centimeter. Megavolt per centimeter. This is what the answer will get. Vasu, you got minus 1.18. Vasu, can you please cross check where the value went wrong? You are supposed to get minus 0.15 megavolts per centimeter. You are supposed to get. You are supposed to get this E naught. This is the final answer. This is the second answer. Answer B. This is a B. Second part B. This is the previous one was part A. This is part B. Shall we move on? Shall we move on to the next topic? Okay. Consider an abrupt. I think this has come in GATE exam 2014. GATE 2014 for 2 marks. GATE 2014, 2 marks. Consider an abrupt PN junction at T is equal to 300 Kelvin shown in the figure. Okay. The depletion region width Xn naught on N side of the junction is 0.2 micrometers and the permittivity of silicon ESI is 1.04 10 to the power minus 12 farads per centimeter at the junction. The approximate value of peak electric field. In kilovolts. Okay. So this is the simple, sir. This is also simple problem only. Acha is asking E naught peak electric field is asking approximate value of peak electric field. See, this is important, Sanjay. Again, without getting confused, it's going to be kilovolts per centimeter. Kilovolts per centimeter. Epsilon is equal to minus Q by epsilon into ND into Xn naught. We know this is going to be minus 1.602 into 10 to the power of minus 19. Did he mention the Q value? No. Okay. ND value, did you mention the ND value? Yes, he mentioned in the problem here. He mentioned the problem here, ND value. So ND is going to be 10 to the power of 16. Xn naught, did he mention Xn naught? 0.2 micrometers. 0.2 micrometers. So, but this ND is in centimeters. So, answer is also in centimeters. So, convert this 0.2 micrometers into centimeters. That is 0.2 into 10 to the power of minus 6 into 100 becomes. So, this becomes centimeters by E has given. Did he give E value? Yes, he has given E value. Epsilon value. Epsilon value has given. It's going to be 1.04 into 10 to the power of minus 12. It's always centimeters. So centimeters. So just tell me the answer. Very simple. Direct question. This was asked in 2016. This was asked in 2016. So 2014. Tell me what is the E naught value. What is the E naught value? Calculate and let me know value directly. Remember, is asking answer in kilovolts. kilovolts per centimeter. Remember, is asking the answer in kilovolts per centimeter. Kilovolts per centimeter. Is asking the answer in kilovolts per centimeter. Minus 30.8. Okay. Minus 30.8 you got. Vasu, did you get? What did you get, Vasu? Vasu, did you get the same answer? Shall we move to the next problem? Correct answer only. Sanjay, correct answer. I'm just waiting for Vasu's response. 30.7. Okay, minus 30.7. If you don't get this 1.6, simply I think you'll get minus 30.68 or 67 or something you'll get. This is okay. Right answer only. Both of them are right. Both of them are right. Correct was. Next we'll go to the next problem. The electric field profile in the depletion region of PN junction in equilibrium is shown in figure. Which of the following statements is not true? Which of the following statements are not true? This is saying this is electric field. So far we're discussing same thing, right? It's saying is electric field is saying. This shows an electric field. Listen to me carefully. PN junction in equilibrium shown in figure. Which of the following statement is not true? 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 Okay. So he's asking about electric field. Sir, electric field, see, this is positive means this side is n side, sir. Right? See, earlier what we have studied, like this. Do you have next please? Here I'll let you know, like I'll explain. So for this we have said xn naught, this is xp naught minus xp naught. So if this is what's our Na into Q. This is rho, charge density. This is Nd into Q. If the Nd into Q is positive, how much we get? This is negative. First we got. This is P type and this is N type. So for P type, how did you get, sir? For P type, how did you get, sir? You get like this, decaying. If it is increasing means it is the N type. Decreasing means P type. This is increasing means N type. So for a given in the given formula, in the given figure, what we have is we have like this. This side is positive. This side is positive. This side is negative. Decaying. This is increasing. So what would be this side is going to be N type, sir, now. This type is going to be P type. So your PN junction diode looks like this. This is N and this is P. Did you get the point? Did you get the point what I'm saying? Did you get the point what I'm saying? So this side is N, this side is N, and this side is P. This side is N, and this side is going to be P. Okay. Earlier this was here. This is said P type. This is P type, and this is N type, because this is decaying. This is increasing. So for N type, it will be this. For N type, it will be increasing. So now we'll see the left side of the junction. Not true. The left side junction is N type and right side is P type. Yes, this is right. This is true only. This is true statement. Okay. Both N type and P type depletion regions are uniformly doped. It could be. It could be. Why not? Why not? Yeah, the depletion regions can be uniformly doped. What is there in it? Okay. The potential difference across the depletion region is 700 millivolts. Who knows this? Who knows this? How did you calculate this? How can you calculate this? How can you calculate this? So this can be calculated V naught. V naught, how will you calculate? V naught is going to be. How will you calculate? How will you calculate? So he's saying V naught. V naught is how much? How will you calculate V naught is equal to, can I write? Half into base into height. So how much is the half? What is the base value? What is the base value? This is going to be 1.1 micrometers, yes or no? 1.1 micrometers is base. Height is equal to 10 to the power of 4. 1.1 into 10 to the power of minus 6 into height is equal to 10 to the power of 4. So how much you will get? How much you will get, sir? How much you will get? Calculate this. 1.1 into 10 to the power of minus 2 by 2 will be 0.5. 0.5 to 10 to the power of minus 2. So 5 millivolts. Yeah, V naught is going to be 5.5 millivolts. But what is saying, sir? He's saying the potential difference across the depletion is 700 millivolts. 700 millivolts. So this statement is not true. We'll see also fourth one. The P-type region has doping concentration of 10 to the power of 15. Then the doping concentration of N-type will be 10 to the power of 16. Yes, obviously the concentration may be higher. N region concentration will be very higher. So no issue. So the option C is wrong answer. Option C is not right answer. Option C is not right answer. So what you'll get is, you get 5.5 millivolts. You get 5.5 millivolts. 5.5 millivolts. So option C is right, wrong answer. Next problem. Next problem. Consider a silicon PN junction. Consider a silicon PN junction with a uniform acceptor concentration. Consider a silicon PN junction. Consider silicon PN junction with a uniform acceptor doping concentration of 10 to the power 17 per centimeter cube on P side and a uniform donor concentration of 20 per 16 per on N side. No external voltage applied to the diode. Given kT by Q is 26 millivolts, Ni is equal to 1.5 10 to the power of 13, 10 to the power ESI is equal to epsilon naught, and epsilon is equal to what? Q is equal to what? The charge per unit area, the charge per unit junction area in the depletion region on the P side. So what is asking? Is simply asking for Q plus by A. Is asking for Q plus by A. Q plus by A. Q plus by A, and I have given the value of, this is I think we got in 2016 for 2 marks. For 2 marks. Is asking Q by A. What is Q plus? Q plus what you know, sir? Formula minus Q into NA into A into XP naught, XN naught, XP naught, XP naught, XP naught. So by A means simply you have to get minus Q NA XP naught. We're happy that we got Q and NA, but we don't know XP naught. We don't know XP naught. How to calculate this XP naught? How to calculate this XP naught? He has given NA and D also is given. NA and D also is given. So how to calculate this XP naught? We need to calculate, sir, end of the day. So how to calculate XP naught? What we know, simply we know XP naught is equal to W into ND by ND plus NA. ND plus NA. ND plus NA. Did he give any value of concentration in silicon? No external voltage is applied. No external voltage is applied, he's saying. No external voltage is applied. Okay. We need to calculate the value of W. What you know W value? W is going to be square root of 2 epsilon by Q into 1 by NA plus 1 by ND. Sir, formulas you need to remember V naught. If you know the value of V naught, then you can substitute W. If you know W, you can substitute the value of W in XP naught. So if you know the value of XP naught, you can calculate the value of this. So, but how to calculate W? You don't know. You have NA, ND, epsilon and A. What do you know? Did you know what is V naught? V naught is again what you know, Vt into ln of Na Nd by Na square. This we know. Na square. So now what we need to do, sir? First we need to calculate V naught. From V naught we'll get W. From W we'll get XP naught. From XP naught we will get the value of Q plus by A. Q plus by A. Q plus by A. So what is the V naught value? Now substitute, simply you'll get V naught is equal to Vt is 26 millivolts. Did he give? Yes, 26 millivolts he has given. It's going to be 26 millivolts into 10 to the power minus 3 into ln of Na and D. One is 10 to the power 17, the other one is 10 to the power 16. By Na is 1.5. So simple. 10 to the power of 17 into 10 to the power of 16 by 1.5 into 10 to the power of 10 whole square. So what you'll get is V naught is equal to 26 into 10 to the power of minus 3 into ln of 10 to the power 33 by 1.5, 1.5, 15, 15 is 225, 2.25 into 10 to the power of 20. So calculate V naught first. Tell me what is the V naught value? Tell me what is the V naught value? Tell me what is the value of V naught? Yeah, lengthy problem. Correct, Vasu. Lengthy problem. Lengthy problem. Correct. Correct, Vasu. But we need to do because he has given it for 2 marks. Vasu, see, this is 2 marks problem, not 1 mark problem. 2 mark problem. 2 marks problem. The thing is, first you need to get this idea, Vasu. First thing is you need to get the idea. If you get the idea, you are done with the problem. Quickly you can do it. Quickly you can do it. Quickly you can do it. How much you got? 0.757. Okay, Sandhya. So 0.757. Approximately, I can also say 0.76 volts. Okay, once I get this, next I need to calculate W value. W is going to be square root of 2 into epsilon is nothing but 12 into 8.85 into 10 to the power of minus 14. I think he has given. I'm just thinking that he has given same value. Yeah, 8.8 into 14. This is 12 into epsilon. Okay, same value I got. By Q 1.602 into 10 to the power of minus 19 into 1 by 10 to the power of 17 plus 1 by 10 to the power of 16 to V naught is 0.76 you use and calculate the value of W. Once you calculate the value of W, you can calculate XP naught. XP naught is going to be how much? W into ND by NA plus ND. So calculate the value of W. ND is 10 to the power of 17, I think. Donor concentration 10 to the power 16. Calculate the value of W. 3.32. Okay. 3.32 what? 3.32 what? 3.32 millivolts, microvolts. What? What did you got? Micrometer. 3.32 centimeters. Please cross check. You are supposed to get 3.32 into 10 to the power of 5 centimeters. You are supposed to get. You are supposed to get 10 to the power of minus 5 also, Sandhya. Sandhya, you are supposed to get 10 to the power of minus 5 also. Please cross check. So once you got the value, it's going to be 10 to the power of 17 plus 10 to the power of 16. 3.32 into 10 to the power of minus 5 you are supposed to get. So once you get this, XP naught is going to be, I'll write the XP naught value, you get 0.303 into 10 to the power of minus 5 centimeters. 10 to the power of 5 centimeters. 10 to the power of 5 centimeters. Then now you calculate Q by A. Now calculate Q by A minus Q NA into XP naught minus 1.602 into 10 to the power of minus 19 into 10 to the power of 17 into, we'll do it in the next page because I think you are unable to see it. Are you able to see it? Are you able to see it? If it is okay, then I'll write here itself. Xp naught is going to be 0.303 into 10 to the power of minus 5 centimeters. So Q plus by A is going to be, I'll write directly, minus 4848 nanocoulombs per centimeter cube. Did he ask? He is asking in nanocoulombs. Remember this also. He is asking in nanocoulombs. 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 So minus 48.48 nanocoulombs per centimeter cube. You do the problem, you'll get this value. Is that fine, Sanjay? Just cross check where the mistake went on. Where the mistake has happened. Where the mistake has happened. So you are supposed to get minus 48.48 nanocoulombs per centimeter cube. Nanocoulombs per centimeter cube. Nanocoulombs per centimeter cube. Okay, we'll go to the next problem. Go to the next problem. How many problems we have? We have 2 problems. We will finish off as early as possible. This is GATE 16 2000 marks. GATE 16 2 marks question. GATE 16 2 marks question. Consider a region of silicon devoid of electrons and holes with an ionized donor density of Nd plus 10 to the power 17 centimeter. The electric field at x is equal to 0 is 0 volts per centimeter. Okay, and electric field at XL is equal to 50 kilovolts per centimeter in the positive x direction. Assume that the electric field is 0 in the y and z directions, all the points. So given Q is equal to something, epsilon is equal to Q for silicon, the value of L is asking us to calculate the value of L. Is asking us to calculate the value of L. Is asking us to calculate the value of L. So what he has given, electric field epsilon at x is equal to 0, you have 0. At x is equal to L, you have 50. Acha, he is saying, he is mentioning, sir, he is mentioning dE by dx. Yes or no? dE by dx is mentioning. Is mentioning dE by dx. dE by dx is mentioning. Is equal to what, sir? We know dE by dx is going to be rho by epsilon. Rho by epsilon. Very simple problem. Only thing is you should know this formula. If you know this formula, you can solve the. You'll get the answer very easily. Know the formula, you can get easily. So simply what you can get, sir, from 0 to minus 50k, it changes to 0 to minus 50k by 0 minus L dE by dx is equal to so you will get dE by dx is equal to rho by epsilon that gives 0 minus 50k by 0 minus L is equal to what? Rho is nothing but Q into Nd or Na. Did he give Nd plus? He has given Nd plus by epsilon. So you will get 50K by L is equal to Q is 1.602 into 10 to the power of minus 19 coulombs to Nd plus how much he has given? 10 to the power of 17 per centimeter cube. 10 to the power of 17 per centimeter cube by what is epsilon? Epsilon is going to be 1.17 into 8.854 into 10 to the power of 14. 11.7 into 8.85 into 10 to the power of minus 14. Minus 14 into the power of minus 14. So what's the value of L? Calculate the value of L, you will get something. Calculate the value of L, you will get some value. Calculate the value of L. He's asking in nanocentimeters, sir. He's asking in what? He's asking in nanometers. He's asking in nanometers. He's asking nanometers. I'll do one thing. L is going to be 50 into 10 to the power of, that's what is changed, right? 50K. 15 10 to the power of 3 into 11.7 into 8.85 into 10 to the power of minus 14 by 1.602 into 10 to the power of minus 19 into 10 to the power of 17. 10 to the power of 17. This is in centimeters, this is in centimeters. So no issue, centimeter square will get cancelled. This is in kilovolts per centimeter, I think. Yeah, kilovolts per centimeter. So no issue of centimeters. No issue of centimeters. Centimeter will get cancelled. Centimeter per centimeter. Cube per centimeter square. This is going to be anyway. Yeah, per centimeter. So he's asking in nanometers. So calculate the value of L. Calculate the value of L. L you got nanometers. Sandhya, this is per centimeter cube. This is per centimeter. This is per centimeter. So 1 centimeter will be up here. 1 centimeter will be up here. Vasu, you got the right answer, Vasu, actually. Vasu is saying, Vasu's answer is going to be 3.23 into 10 to the power of 5 nanometers. But into centimeters, we did not convert, Vasu. We did not convert in centimeters. Actually, what we'll get is, original answer is not answer. The answer what we'll get is 3235.78 nanocentimeters will get. Nanocentimeters will get. So what value originally get is asking nanometers. So you'll get 323578 nanometers. 3235 nanometers. You just see, this is centimeter cube, this is centimeter cube, this centimeter per centimeter will be left. So centimeter will go up, centimeter will go up. So 10 to the power 19, 10, this is 10 to the power of what? So this is 10 to the power of minus 2 is here, 10 to the power of minus 2 is here, it will go to 5. So it will get 10 to the power of minus 9. 10 to the power of minus 9 means 50 into 11.7 into 8.85 by 1.602 will get 50 into 11.7 into 5.85 into 10 to the power of minus 9 centimeters will get by 1.602 by 1.602. So overall you will get 32.3578 nanometers. 32.7825 nanometers is the answer you will get. Okay. Okay. Next we will see. Hopefully this is the last problem. This is also previous gate problem only. I don't remember the year. So in a forward bias PN junction diode, the sequence of events that best describes the mechanism of current flow. In a forward bias PN junction diode, the sequence of events that describes the mechanism of current flow. Forward bias is saying, okay. He's saying forward bias. So this is a P region, this is N region, this is P region and N region, P region and N region. So he's saying injection, diffusion, recombination of magnetic carriers, okay. Injection, subsequent drift, generation of magnetic charge carriers. Generation of magnetic charge carriers will never happen. Extraction, subsequent diffusion, generation of magnetic charge carriers. So the word of generation of magnetic charge carrier itself is wrong. Extraction and subsequent drift and recombination of. So we either it should be A and D. What do you mean by extraction? What do you mean by extraction? It has to extract something from where? Somewhere. So, but now there is no something called extraction. Always injection. So here the charge carriers from P to N will inject. From P region to N region, there will be an injection of charge carriers. Then they will diffuse. Then they will diffuse. Then they will recombine. Then they will recombine. Then they will recombine. This is injection. First is going to be injection. Then it is going to be diffusion. Then recombination. We have studied in detail what's happening. We studied in detail what will happen. What will happen. So injection, diffusion and recombination. Injection, diffusion and recombination is what happens. Injection, diffusion, recombination is what happens. Okay. Injection, diffusion, recombination is what happens. Okay. So what is the answer, sir? Answer is A. Answer is A. Okay. So this is what today's class. We have a lengthy discussion on problems on PN junction diode. Tomorrow we will discuss. In tomorrow's class we will discuss. In tomorrow's class we will discuss. I mean to say Monday. In the next class I should say. In the next class. In the next class we will discuss junction capacitances of diode. Junction capacitances of diode. Junction capacitances of the diode. So you have a CD, diffusion capacitance and transition capacitance. Diffusion capacitance. And then you have transition capacitance. We'll discuss these three. If possible, some problems also on this. Many problems are also asked based on these formulas. So for some problems we'll discuss on Monday. On Monday. Tomorrow we will have a in the morning session also, early in the morning session, we'll have 2 hours on app, Unacademy app. We'll have 2 hours, and from Monday again we will have regular classes. From Monday we have regular classes. Okay, we'll catch up on Monday. We'll catch up on Monday. Right? Thank you. Thank you for your patience. In the Telegram channel, I am going to post the today's class. In Telegram channel, I am going to post today's class notes, complete class notes. I am going to post in another 5 minutes. Another 5 minutes. Just see and practice as many problems as possible. These problems are, I can't discuss all different types of problems in the same class. So I would request all of you to listen, practice new problems, as many problems as possible. As I told you, gate is all about how you practice, how much you practice. Gate is all about how much you practice. Thank you, Vasu. Thank you. We'll catch up tomorrow. So meanwhile, before leaving, just listen to me what I'm saying. So we have another YouTube. These are the YouTube channels which we have. We have Creatrix Gate EECEIN for Creatrix, that is for triple students, EC students, and intermediate students. We have Creatrix, and Unacademy Gate for mechanical engineering, production engineering, and engineering sciences, and Unacademy Gate for civil engineers. We have Unacademy Gate for civil engineers. We have, and then we have engineering Pathshala. Then we have Unacademy Computer Science. We have Unacademy Computer Science. We have Unacademy Gate questions. Also separately. Unacademy Gate Telugu, where I am teaching. Along with this, we have mathematics. We have communication systems. And we have digital electronics. And we have other subjects also going on. Aptitude is also going on. And we have something called electrical junction also. We have electrical junction also. So try to follow all these things. And we'll catch up in the next class. Thank you all. Don't forget to like, share, subscribe, and hit the bell icon. If you're already done, that's great. So we'll catch up in the next class. Thank you.